This is the part 3 of the lab, free fall lab calculating time. So from the first 2 labs, you should have a better understanding about free fall. So now what we're gonna do is I will have a metal ball and dropping from 3 different locations. First location is a black cabinet. The first thing I need to do is measure the height of the black cabinet. This is the black cabinet, so this is the location 1. What I need to do is put the measuring on the bottom and to all the way to the top here. So just be aware I am going to do it to on the top, which is 52 inches or 4 feet 4 inches. This is the second location, the door frame. What I'm going to do is I'm going to measure the height of the door frame.
So it's about 55 and half. Yeah, I would say it's a 85 and half inches.
This is our last location, the table. So I am going to measure from the bottom, which is the floor, to the top. So it's about 33.6 inches. So here's the data. Delta X is all in inches. So the first thing you need to do is convert them into centimeters, then to meters. Or if you are comfortable with a matrix prefix, you can go right into meters, because understand that we are using meters per second as the units for the velocity. So that might help to do the first step, is to convert your units. After you convert the unit, be aware you have your delta X, but also one thing you need to understand, because the ball, if I'm dropping it, it's starting from rest. So from rest, that means your V initial, velocity initial is 0. So you have delta X and V initial is equal 0 meters per second. And you know your gravitational force or your free fall acceleration is 9.81 meters per second squared. Now you're trying to calculate delta T. Looking through your equation sheet, from 1 to 6, pick an equation you think is the best to use to calculate delta T. Do your calculation first for 3 of them, then I will post the data for the trials that I'm dropping ball at each location. Then from that, you can calculate your percent error. So here is a demonstration of what's going on after your calculation is done. You will place a metal ball, try to get to the edge as much as you can, so close to the distance or displacement that you measured. Then you have your partner have stopwatch ready, and you drop the ball. And the first click, that was your time. So after the trial, here is my time. For location 1, I end up at 0.60 seconds, 0.51 seconds, and 0.55 seconds. Location 2, I end up at 0.72, 0.65, 0.75. Location 3, I end up at 0.45, 0.40, 0.47. Just keep remind you, calculate changing time. That's a set value you will use, and then be aware there's absolute value there, so your percent error should be always positive. The example sheet I will share with you in Teams, so let me know if you have any questions.